Alright guys, we are going to try this again. So section 5 and section 6, we'll start off with talking about isotopes, and I have talked to you guys about how it's okay that we round when we're looking at weights on the periodic table, which I'm going to pull up right now while I'm talking to you, because it's not the actual weight of the element anyway, it's just an average, and that's what we're going to be looking at in this section. And I'm going to need a periodic table pulled up here. So that's why I'm getting one right now. That hopefully will have weights and everything on it. Find a good one to pull up. Alright, so anyways, going back to this. It says isotopes are atoms of the same element that have different mass numbers. So it's the same element, but they weigh different amounts. So I'm going to ask you these questions so we can see where that different amount is coming from. So it says electrons, protons, and neutrons. Which ones can change? Well, I'm going to highlight the ones that can change. And electron number can change. And neutrons can change. Protons will not change. If protons change, then you're changing the element. Alright, the next question. Electrons, protons, and neutrons. Which ones have a weight? Well, I know that protons plus neutrons give me my atomic mass. So, knowing these two things, knowing that electrons and neutrons are the only things that can change, and knowing that my protons and my neutrons have a weight. So which subatomic particle is changing to make an isotope? That is a neutron. I forgot to erase that from when I did the notes the first time. But it is neutrons then, right? Because it's got to be protons or neutrons, and protons cannot change. Alright, so a nuclear symbol. Label the mass number and the atomic number. It's, once again, I forgot to erase these. They're already there. This is the nuclear symbol. This is how it's written. Sodium or whatever element you have. The mass goes on top, the atomic number on bottom. So the information that I can get from this is I can get my proton number. I know it's the same as my atomic number, which is 11. And right now, if I have 11 positive protons, I'm going to have 11 negative electrons. Now neutrons, I'm going to subtract mass, or 23 minus 11, and that is going to give me 12. Right, so that is how I can figure out my protons, electrons, and neutrons based off of this nuclear symbol. And they're all written the same. Alright, so my learning check. Naturally occurring carbon consists of 3 isotopes. There's 3 different types of carbons. Now I added this 6 down here. When I was doing the notes, I could not figure out how to get a subscript and a superscript at the same time. So I added the 6 now. State the number of protons, neutrons, and electrons in each of the following. So if you look at my carbons, they're all atomic number 6, which means the protons, I'm going to do carbon 12 here, is 6. The protons here are 6, and the protons for carbon 14 are 6, right? If that number changes from like 6 to 7, then you're no longer carbon. That's your atomic number. Alright, so on all of these carbons, all 3 of these carbons, if I have 6 positive protons, I am going to have 6 negative electrons. For carbon 12, carbon 13, and carbon 14. Now this is what changes here, my neutrons. 12 minus 6 is 6. 13 minus 6 is 7. And 14 minus 6 is 8. Alright, so yes, they're all carbon. They have different weights, and they have different weights because they have different number of neutrons. Proton number will not change. Alright, so on this learning check, write the nuclear symbol for the atom with the following subatomic particles. So, man, if I have 8 protons, I'm going to go to my periodic table. Okay. Let me find a periodic table that's actually going to work here. This one will. And I'm looking for element 8. Guys, I cannot find. There we go. So element number 8 is oxygen. So I'm going to go back here and I'm going to do my superscript here because oxygen weighs 16. I'm going to put O. Now, like I said, I don't know how to do the superscript and the subscript, so I'm going to have to go into drawing here. And I'm going to have to put, well, here, I think I can just do a new text box like this. And I'm going to write 8, and then I'm just going to slide it up underneath there. So that's what it would look like. That's A. Now for B, I need to look at, okay, 17 protons. Who has an atomic number of 17? And that is chlorine right here. So I'm going to do my superscript. Chlorine, by the way, weighs 35.5. So we'll round that up to 36. A lot of times when I'm doing math, I'll keep 35.5. And then chlorine. No. Get rid of that. Chlorine. And then I'm going to write 17. I'm going to slide that up underneath there. And that is the nuclear symbol. Now the next one has 47 protons. So I'm going to look for element 47, and that is silver. Alright, guys. Let's see what is going on with my computer and why it's not plugged in. It is plugged in. Alright, I'm showing my computer is plugged in. Alright guys, so we'll see how far I can get with this. So silver. So I'm going to do silver. Now it weighs 107. So let's see here, I'm going to do that. 107. And then there are 47 protons, so I'm going to write 47. I'm going to slide it up underneath there. Alright, so that's A, B, and C. Now here's the next learning check says, which of the following pairs are isotopes of the same element? Well, that means that they have the same atomic number if they're the same element, right? So A is out. B is the right answer because B's atomic number for this element and this one is 6, which would make it carbon. This one is out, C's out because they're not the same. Number 2 says, in which of the following pairs do both atoms have 8 neutrons? Well, 15 minus 8 is 7. 15 minus 7 is 8, so that's not it. 12 minus 6 and 14 minus 6 are different. If you do 15 minus 7 and 16 minus 8, they both have 8 neutrons. So the answer would be C. Alright, atomic masses. Give the mass of an average atom. So anyways, this is how they get the mass on the periodic table. So take magnesium, for instance. There are 3 different types of magnesium. Now they are in different abundances on Earth. So what they do is they will take, if we scroll down here, magnesium 24 weighs 23.985. We find that about 78, almost 79% of the time on Earth is magnesium 24. So they're going to take 23.985 times. Really what they're timesing this by is 0.7870, and you get 18.88. They're going to do that for magnesium 25 and magnesium 26. They're going to multiply by the percent abundant, and then you get these numbers right here. When you add all those up, you get 24.31, which is the mass on the periodic table. So it's just an average. So that's why it is okay that we round these masses. Now this learning check, using the periodic table, specify the atomic mass. So all you're doing here, guys, is like for A, calcium. I'm going to find calcium on the periodic table, and it is 40.076. I think is what that says, 40.078. So you are literally just going through your periodic table and you're writing the masses there that you find off of your periodic table. All right, so that's section 5. Lise got through that. We're going to, I don't know if I can get through section 6. I'm not for sure why my computer is all of a sudden saying that it is not plugged in. So anyways, I'm going to stop there. Hopefully you guys can then, or I'll try to get this going and I'll post the section 6 video here in a little bit.